Good afternoon, students. Let me get rid of this little thing here. There we go. Good afternoon, students. Welcome to section 4.0. We're going to talk about exponential properties, and we're going to review those properties that you've learned in the past. Let's go to work. Let's start things off. There are basically 5 properties that we're going to deal with today in section 4.0. And I'm going to work my way through those properties right now. Here they are. Here are the 5 properties. The zero power property, multiplication property, division property, power to a power property, and then we'll talk about negative exponents. So let's get into it. Let's start with the first one, the zero power property. Sorry about that. The zero power property says anything to 0 power equals 1. Okay, so I'm going to jump in here and give you several examples. Let's say I have 5 to the 0 power. What does that equal? 1. How about 123 to the 0 power? What does that equal? 1. How about x to the 0 power? What does that equal? 1. And this last one is my favorite. What is yo mama to the 0 power? That's right. Yo mama is number 1. So anything, the 0 power property says anything to the 0 power is 1. That makes it pretty easy. Let's say I have something crazy like x, y, z, all of that raised to the 0 power. What's that going to equal? That's right. It's going to equal 1. So that's probably the simplest property we have. Anything to the 0 power is 1. The second property is the multiplication property. And when we multiply the same base we add the exponents. When we multiply the same base, we add the exponents. And just as a quick little refresher here, if I have 3 squared, 3 is the base, and 2 is the exponent. Oops. Exponent, aka the power. Okay. So for multiplication, we multiply the same base, we must add the exponent. So let's get some examples here. So let's say I have 3 squared times 3 to the 4th. Well, that ends up being 3 to the 2 plus 4, which is 3 to the 6th. Now, how does that work? Why does it work like that? Well, if we remember, let me rewrite the same problem again with another explanation. If I have 3 squared times 3 to the 4th, well, that's really 3 squared means 3 times 3, right? And I'm going to multiply that times 3 to the 4th, which means 4 3's multiplied together. So 3 times 3 times 3 times 3. Now, how many 3's do I have there? 1, 2, 3, 4, 5, 6, which is 3 to the 6. So now you can see that happening all the way out. Well, what if I had, I don't know, variables? X to the 3rd times x to the 5th. Well, as long as the base is the same, we simply add the exponents. So this would be x to the 3 plus 5 is x to the 8th. What if I had x squared times y cubed? Can I put those together? Absolutely not. We must have the same base. Okay, so this is not possible. Well, what it actually does is we just end up writing it x squared y cubed, which is the same thing, but we don't actually add the exponents there. So when we multiply, we add the exponents. Well, what happens when we divide? Well, when we, don't mind JC, she's just, making herself a sandwich or something. When we divide the same base, we subtract the exponents. And that kind of makes perfect sense because you know how addition and subtraction are opposites of each other, and multiplication and division, those are opposites of each other as well. So if as long as I have the same base, let's say we have, get in here a little bit, 3 to the 5th over 3 squared. Well, that would be 3 to the 5 minus 2, which is 3 cubed. And we could evaluate that, but I'm not going to for right now. Now, why does this work? Well, 3 to the 5th over 3 squared is the same thing as 3 times 3 times 3 times 3 times 3. 5 threes there. Over 3 times 3. And anytime you have the same thing over top of itself, that equals 1. So those kind of cancel themselves out. And I end up with just 3 threes on the top, which is 3 squared. Excuse me, 3 cubed. And that's how that works. So when we divide and we have the same base, we subtract the exponents. So what if I had x squared over x to the 4th? Well, that would be x to the 2 minus 4, which is x to the negative 2. Is that a problem? Well, we'll come back to this negative here in a second as we talk about negative exponents. So we'll come back to that one. Next, power to a power. When we raise an exponent to another exponent or power, we multiply the exponents. For example, if I have 2 cubed raised to the 2nd power, I'm going to multiply those exponents to get 2 to the 3 times 2, which is, getting ahead of myself, 2 to the 3 times 2, which is 2 to the 6th. Well, how does that work? Well, this exponent on the outside means I got to take what's on the inside and multiply it times itself. So 2 cubed squared means I got 2 cubed times 2 cubed. And 2 cubed really means 2 times 2 times 2, right? Times 2 times 2 times 2. And how many 2's do I have here? 1, 2, 3, 4, 5, 6. So 2 to the 6th. You can see how when we raise a power to a power, we got to multiply those exponents. So what if I gave you x to the 3rd raised to the 5th power? That would be x to the 15th. How about this one? How about if I give you x squared over y to the 4th raised to the 5th power? What would that look like? Well, I got to raise everything inside. I got to multiply this 5 times everything. So that would be x to the 10th, because 2 times 5 is 10, over y to the, y to the 5 times 4 is 20th. Now, there's nothing else I can do here because those are different bases. But that's an example of raising a power to a power. This last property about negative exponents is maybe the most difficult one for students to grasp. But negative exponents, this may be called the reciprocal power. Because whenever we see a negative exponent, we must flip it. So let's say I have x to the negative 2. Well, that means I got to write the reciprocal, which is 1 over x squared. What if I have 1 over x to the negative 5th? Well, then I have to write the reciprocal, which is x to the 5th. It's really over 1, but we don't have to write that over 1 part there now, do we? Now, here's the thing about reciprocals. If I were to multiply reciprocals, 1 times x to the 5th is x to the 5th. X to the negative 5th times 1 is x to the negative 5th. If I have let's forget about that for a second. But when we multiply reciprocals, we should end up with, they should multiply together to get 1. So what you need to remember for right now is when we see a negative exponent, we must flip it. So let's go back up here to this one that we saw earlier. Let me change my color here. So this then would become 1 over x squared. So those are our 5 properties, our 5 basic properties that are dealt with in section 4.0. Hope that helps you understand what's going on. Y'all have a great day.